All right, so now we are on to our next grouping of compounds, the carboxylic acids. Okay, so first we're going to talk a little bit about the structure of the carboxylic acids. They are terminal. So you've got an R group, a carbon, 2 oxygens, and a hydrogen. The way this looks, let me draw this out. So I have my R group bonded to a carbon. So we have both a carbonyl, so the functional group is called a carboxyl, and that's because we have a carbonyl. So our carbonyl is right here, and we also have our hydroxyl, which is right here. So very clever carboxyl. The family or molecule type would be a carboxylic acid. So when looking at the polarity of our compound, it's definitely polar in that carboxyl region. The intermolecular forces would be hydrogen bonds. It can both form and accept hydrogen bonds. So the lone pair on the oxygen would be a hydrogen bond acceptor, and then the hydrogen would be a hydrogen bond donator. You can also see from mole view that the structure, you can see definitive negative, partial negative sections and partial positive sections, and that would be those red and blue areas in there. So definitely very polar, definitely has some hydrogen bonding. All right, next is the solubility. These are going to accept a hydrogen bond from water. They're actually weak acids, so they are going to donate an H+ to ionize in water, and this is going to make them very soluble. So again, we talked about acid-base reactions sort of in the amines section. The same sort of thing is going on here, only this time we're dealing with an acid. So that acid, the carboxylic acid, is donating its H+ to water, which gives us the hydronium ion. And we're going to talk about this in a later podcast, but it's also going to form a carboxylate ion. And remember, anytime we have something charged, it is going to be very soluble in water. And then last, our phase changes. Again, we've seen this on repeat. Notice now that the carboxylic acids, they are going to have the highest melting and boiling point. So they surpass alcohols.